Welcome to the Authority File. I'm Bill Mickey, your host and the editorial director at Choice. My guest for this series is Simon Dalby. Simon is a professor of geography and environmental studies at Wilfrid Laurier University in Waterloo, Ontario, where he teaches in the Balsillie School of International Affairs. He's also a senior fellow at the Center for International Governance Innovation. Simon's latest book is called Anthropocene Geopolitics, Globalization, Security, Sustainability. The title was published by the University of Ottawa Press in early 2020, but it was overshadowed by the subsequent pandemic, so we're very happy to finally get a chance to speak with Simon about it. Fair warning, we're about to engage in a long discussion about the environment, sustainability, and what governments around the world are doing about it. As you can guess, it's a daunting subject with few bright spots. Nevertheless, Simon's book lays out a compelling case for situating our thinking around forward-looking strategies that can guide us toward peaceful outcomes. This series is brought to you with support from University of Ottawa Press. In this second episode of our four-part series, we talk about the geological era we're currently in, the Anthropocene. We'll look at what defines it and why it's having such a profound impact on the way we think about science and just about every other research discipline. We'll also learn which animal bones will form the most common fossils a million years from now. So we can't really get into a discussion of your book without first, I imagine, talking about the Anthropocene period, which we're, I think, arguably, I take it, we're now in. How do you define this period and why has it had such a profound impact on the way we think about not only science, but all kinds of other disciplines?
Yeah, the Anthropocene emerged as a word that coalesced an awful lot of things about 2 decades ago. It really has become in part of sort of popular discussion a decade ago. I think it was March 2011 that Elizabeth Colbert had a cover story in the National Geographic magazine where she used the term, and a couple of months later, in I think it was May 2011, the Economist magazine actually put the word and a strange image about an artificial world on the front cover. So we sort of got the American take on it, and then a couple of months later, the Brits were talking about this as well. And really, since then, the word has proliferated into all sorts of different places. It's a little tricky because it's obviously a geological formulation. It's supposed to suggest a new period in Earth's history, but geology is all about the past, and this is the present. So there's this endless debate about, well, should we be calling the present in terms of words that are derived from a discipline that really deals with the world's ancient past? And yet one finds the term Holocene, which is what has been conventionally used to refer to the recent past right across the science disciplines. Somehow, at least to Paul Crutzen 20 years ago, it didn't seem like this was any longer the adequate word. We needed something, so Paul Crutzen argued, that marked the fact that we now live in a period where human activity, or at least the activity of industrial, urbanized consumer humans, is beginning to dramatically change how the world actually works. It's changing how the world works in ways that, if you imagine yourself as a geologist 2 or 3 or 4 or 10 million years in the future, looking back at this period of the planet's history, you would realize that something really weird happened. Mm-hmm. Because suddenly lots of things seem to change incredibly rapidly. The acidification of the acid level of the oceans changed. Suddenly there was this dramatic spike in carbon dioxide in the atmosphere. Suddenly you begin to find all sorts of rocks that have holes in them. Tunnels and mines have been, making large numbers of geological phenomena look like Swiss cheese. You would discover that there was a whole series of new sedimentary deposits, layers on beaches of strange sort of carbon-rich deposits, which would, of course, be decaying plastic, the so-called plastiglomerates, washing up on beaches and actually turning into a form of rock. So it's perfectly obvious that, if you get into your imaginary time time travel capsule and go 10 million years into the future and behave like a geologist and look at recent sediments, something really weird happened to the planet. And what was really weird is us,
Right.
or at least industrial us, making all sorts of things, turning rocks, as in fossil fuels, back into air at a most extraordinary pace. It's unparalleled in the history of the planet. And this, to many people, would suggest that we actually need to designate present circumstances in terms of something new in terms of the history of the planet, hence the Anthropocene, because Anthropos is us, humans. The age of humans is at least the age that has been marked by human activity. That's the origin of the term. If you are a fossil hunter 10 million years in the future, you will suddenly discover that lots of species went extinct. And that again is as a result of our dramatic changes of the vegetation and the habitats across the surface of the earth. You will also find probably this sudden emergence of all sorts of new fossils, massive amounts of bones of tiny little dinosaurs, in effect, what we call chickens, because chickens are everywhere, and their bones are showing up in sediments all over the planet. So indeed, the fossil that may dominate this period, if you're thinking geologically, may well be chicken bones. Because we are changing how the world works, and we are changing the species mix, we are changing the atmosphere. We are literally, by mining and digging up coal and all the rest of it, turning rocks back into air, but also making holes in all of those rocks in completely novel ways. There's no equivalent in the prior geological history of the planet. For all those reasons, it makes good sense to Earth systems folks to say that we live in a new period. Then you get into all the technical details about, well, how do you define a period and what's the difference? Are those chicken bones, well, are they really going to be a sedimentary marker that allows us to and then most recently, people who suggest, well, let's just cut to the chase and not worry about whether it's an epoch or an era or a period in geological terms. Let's just call it an event and be done with it. Mm-hmm. But clearly something dramatic is happening, and it needs a name to mark the new circumstances in which we are living. Hence, the term Anthropocene seems to have stuck. Although, of course, there are endless debates about whether it should be the Capitalocene or the Pyrocene or various other things.
Okay.
But clearly, we need a name for our new circumstances, and the Anthropocene seems to be the one that stuck.
Right. So, Simon, can I ask, like, what was, the urgency then to whatever name we ended up with? Is it just simply because we're unique in the fact that we're sort of straddling this massive change in sort of the global environment, and which is sort of not customary with the way, as you mentioned earlier, that we name these things. We tend to name these things when we're looking into the past, but we're sort of acting out of the ordinary in the sense that we're naming this thing now. What's the rush, I guess, is my question in terms of having to name it.
Well, part of the rush is simply that we need to recognize that we are living in new and different circumstances, and that the rules from how the Earth system worked through that long period that geologists look at, that's now changing because there is something new in the system, and what's new basically is our industrial systems. And all the stuff we're making. I haven't mentioned concrete. In practical terms, concrete is a new rock in the Earth system. Steel is effectively sort of a new process of mineralization in the global system too. And there's no sort of previous equivalent of those processes. We're literally making new materials. When I was a geology student back a long time ago, the joke was that every now and again, and a test where one had to identify different kinds of rocks, some instructor with a sense of humor would put a bit of concrete in, along with the limestone and the granite and everything else, just to see if you catch it. Most of us did catch it. Once we knew that was occasionally a trick, of course, we always had an eye out for whether we were going to get fooled. But sure enough, various people did misidentify them as conglomerates and limestones and various other things. And of course, it was a joke and a trick question in the exam. But it does make the point that humans, particularly with concrete, are literally making new forms of rock. And that is something
Hmm.
new in the history. We haven't had that form of rock in the planetary system before. So we need to do that. But we also need to mark this to recognize that what we are now living through is much more than traditional notions of environmental problem. This isn't just pollution. We've got one factory that's putting some noxious stuff up its smokestack, and then we need to stop it. We're actually collectively operating on such a scale now that we're beginning to change how the whole system works. And we need a language to grapple with the scale of the changes that we're now living through, because some of them are potentially extremely dangerous for the future of civilization and for all of us and our descendants. And we need to recognize that we need to understand the circumstances, how they're changing, and hence act in a way that heads off the more obviously dangerous changes that we've set in motion.
Right. So speaking of that language, you mentioned the phrase planetary boundaries.
Right.
Is that coming into play with the sort of new language that you're talking about? What are those? And
The planetary boundaries argument is really sort of three crucial points in discussing the potential dangers of the Earth system change, which is what the Anthropocene, at least in part, is a word to flag. What people have been saying in Earth systems is we know through the last couple of 100,000 years that humanity can thrive. Well, there's 7 billion and counting of us alive. We're obviously doing incredibly well in planetary circumstances that look pretty much like what the last 10 or 12,000 years have been. We know we've lived in a relatively stable climate, and it's made agriculture, it's made food production, it's made all sorts of things that we take for granted possible. We live in what they've simply called a safe operating space. We know that we can safely operate in a planet that works more or less the way it's been doing until very recently. And once you start using metaphors about space, then obviously where are the boundaries to that space is the next sort of metaphorical term. And there are obviously limits. If we stretch the boundaries of that safe space too far and cross them, we're in deep trouble. Once you start talking about a safe operating space, then we start using metaphors of boundaries. Clearly, there are some obvious ones. We should not cross a boundary in terms of producing too many carbons or chlorofluorocarbons, the CFCs, because of the immense damage that will do to the ozone layer. And so clearly there's a boundary on there in terms of we simply can't make that stuff if we're going to have an atmosphere that's going to allow us to thrive. Clearly, there are also boundaries in terms of things like nitrogen and phosphorus. How much of that can you put into an ecosystem before it becomes completely clogged up and is no longer able to function properly? And of course, there's danger in terms of artificial fertilizers from both those things in various parts of the world system. Clearly,
right.
there are limits to how much carbon dioxide we can put into the atmosphere because it's starting to both acidify the oceans and heat the planet. And if we go on doing that, then we will knock the system completely out of kilter with what we have known for many thousands of years. So there's an upper limit or boundary on how much carbon dioxide we can put in the atmosphere and still have the climate system function in more or less the way that we've known through the last many tens of thousands of years. So there are boundaries to the safe operating space. If we cross those boundaries and then go over a threshold beyond the boundary, it may tip into a completely different system, which might be very much less conducive to human thriving than we have known. So
Hmm.
the language of boundaries is designed to get us to pause before we get to those danger thresholds. And of course, boundaries and borders are more or less the same thing, rhetorically at least. And so, one of the crucial arguments I've been trying to make, and why I talk about planetary boundaries in the book, is to recognize that this is another kind of border that is really crucial to the future trajectory of globalization. And border scholars in particular need to stop and think about these extraordinary material transformations that we're now living through, because they will clearly have all sorts of effects on borders. But we also need to understand that traditional notions of national sovereignty that stops at a state border is in many cases one of the limits to our governance, which is actually making dealing with some of these global problems so much more difficult. So boundaries works in both those ways. And one of the arguments in the book, of course, is that we need to stop and think much more carefully about how we link these things up. And we need to add planetary boundaries into traditional understandings of territorial boundaries if our understanding of borders and globalization is going to be comprehensive enough to be really useful. And that's one of the crucial arguments that I'm making in this book, and trying to get the attention of the borders scholars and the globalization scholars to stop and think about another kind of boundary, because this is one that's absolutely crucial to long-term sustainability for our global economy, for all of us that are tied into this global system.
You just heard from Simon Dalby. Simon is a professor of geography and environmental studies at Wilfrid Laurier University in Waterloo, Ontario, where he teaches in the Balsillie School of International Affairs. He's also a senior fellow at the Center for International Governance Innovation and the author of Anthropocene Geopolitics, Globalization, Security, Sustainability. This episode is brought to you in part by the University of Ottawa Press. Join us next week for a discussion about globalization from an environmental perspective, what environmental insecurity is, and why security concerns have not caught up with climate-related threats.
The problem with climate insecurity and all the rest of it is that North Americans are particularly bad in terms of generating carbon dioxide. If there's a climate threat, well, actually, we're causing it. It's not an external threat to us. We're actually threatening lots of other people around the world by our profligate use of carbon fuels. Right. And hence the geography of this is all backwards, because we're used to external threats that we need to, keep the bad guys out. But in fact, in this case, we're the bad guys because historically we've generated more carbon dioxide per person than most other societies. If there's a climate villain on the planet, it's North Americans.
If you like what you hear, rate us or give us a review on your podcast platform of choice. As always, sponsorship and advertising for the Authority File podcast are handled by Choice's advertising manager, Pam Marino, and all of our episodes are produced and edited by Choice's digital media assistant, Sabrina Kofer. That's all for this week. Thanks for joining us.